In this video, we're going to be revising the arithmetic or linear pattern. Okay, so without wasting time, let's start with number one. They say determine the value of k. Okay, we need to find the value of k. And then I'm given a sigma notation here. Remember, if I'm given a sigma notation, I'm always going to check this thing here, right? This thing here, I'm going to always check this part. This is the Tn. And then I can see that this Tn is arithmetic because the n is to the power 1. So if n is to the power 1, you know it's arithmetic. Okay. So I know that, okay, sigma means sum of what? Of arithmetic pattern. So here I'm either going to use Sn equals to n over 2a plus dn minus 1 into bracket. Then we close, ne? Or I can use this one. Sn equals to n over 2a plus n. It is very important to know how to use both. Ne? I'm just going to use both of them in the first one. As we go, I'll just choose either one of them depending on how I feel the sum will be quicker. Okay, but now I need you to know how to use both. So firstly, guys, you need to write your list down. Your list. So let's list our things. So you list what you are given. So I'm given that this sum is equals to negative 20. So I'm given the Sn as negative 20. And then let us substitute, remember n is 1 here. So you always substitute this number here into Tn. Ne? So basically you have negative 2, you substitute the number at the bottom because that's where you start. And then you can see that that gives us negative 2. That is our a, is the first term, right? Negative 2. And here it's not always going to be 1. It can be anything. You just need to know that you take this, you put it into the formula. It will give you a. All right? We need to get the last term. So the last term, which is L, is given by, basically, remember this give us first term, T first, right? T1. This one at the top will give us T last. The last term will be there. Yeah? So in this case, it's going to be minus 2, and then we substitute k on n. So the last term is minus 2k, basically. All right. And then now I can see that the difference is negative 2. Remember, the difference is basically the coefficient of n on a linear pattern. Right. So the difference is there. Sharp. Another way you can do the difference is this. You can say the difference is basically term 2 minus term 1. And then you substitute 2 on the Tn, so it's going to be minus 2, substitute 2, minus the first term of which we got as negative 2. So you can see that that will still give you negative 2 as the final answer, because this will be a plus here. That will be negative 4. So, yes, but this is too long. You just need to know that the difference is the coefficient of n. Okay, perfect. Then the last thing you need to know how to get is the number of terms, the n. So the number of terms in this case is basically top, which is k, minus bottom, plus 1, which is just k. Remember, the number of terms is the top number minus the bottom number plus 1, which is k. Okay. And then from there, we can proceed now. We can say, let's see. I'm going to use the first formula first and then use the second one. Sharp. So for this one, let's do our substitution. So our n, we said is k. So n is k over 2. Then we have 2. Our Sn as well, it's negative 20. Then we have 2. Our a, we said is negative 2. Then our difference is also negative 2. N is k minus 1. And then this 2, I'm going to remove it by multiplying by 2 both sides. So basically, I'm going to have times 2 here. Sorry, times 2 here. And then another times 2 that side. So this 2 will cancel with that one. And then I have 2 times negative 20, that's negative 40, is equals to k. Inside the bracket, I can see that I get negative 4 here, then minus 2k, then plus 2, right? And then let's see what does that give us. Let's see what does that give us. You have minus 40 is equals to k in bracket minus 2k minus 2. You add like terms, this one and that one. Then you have minus 40 equals to minus 2k squared minus 2k. You multiply the k in. And then now I'm going to move, because I always need the part of k squared to be positive. So I'm going to move these guys on the other side. So that will be positive 2k squared plus 2k minus 40, because it's still that side, then we have 0. Then I can see that 2 is common onto both. So I'm going to have k squared plus k minus 20 equals to 0. And then I can see that, okay, here basically I have this, right? I have k, then I have minus 4 plus 5, right? And then let's see, therefore, k equals to 4, or k is not equals to 5, negative 5. Remember, k is the number of things that we are counting. So we cannot say number of things that we're counting are negative. So k can never be negative. It can never be a decimal or a fraction. Sharp. So now let's see. They wanted us to find the value of k. So the value of k is 4. Let's see. Let's say someone decided to use this formula. Ne? So if you decided to use this formula, your substitution will be negative 20. The end, remember, we said is k over 2. Then a was negative 2, and then we said the last term is minus 2k. All right, ladies and gents. Then you have minus 40, because I'm going to multiply by 2 both sides, equals to k minus 2 minus 2k. I'm sure, ladies and gents, you can see that this step is exactly the same as this step here. You see? So eventually you are going to get the same answer. All right. I'm not going to finish it up. I was just showing you that both formulas works. Okay, perfect. But this one looks longer, because you see, this one you're already landing on step 4, but here you're on step 2. So when I work with sigma notation, I usually prefer to work with this one, because this one is shorter. But yeah, it's very, very important to know how to use both of them. So we can now proceed, ladies and gentlemen. Let's go to the next one. Okay, I'm quickly going to erase here. Let's see. In number 2, they say the sum of n terms of an arithmetic series, is that. Okay. So they gave me the sum of what? Of that. Okay, sharp. And then they say how many terms? So they're asking for n. Must be added to give the sum of. Okay, they gave me that the Sn is 4, 2, 5. Okay. Now this is easy. I can easily just substitute here. So I'm going to have 425 is the same as n over 2 in bracket 7n plus 15. And then we're going to always multiply the Sn by that 2. I'm sure you're seeing the pattern now, so that it cancels this side. So 425 multiplied by 2, that gives us 880. And then you can see that here we need to multiply by n inside, which is 7n squared plus 15n. And then you can see that 0 equals to 7n squared plus 15n minus 850. you remove the 850 on this side, right? So when you're here, you can use your quadratic formula because this number looks big, but I'm going to try to find it. So this is what I do. I'm going to say negative 850 divided by 50. Let's see. I need something that will add to 50, right? So that is too far. 20 and 20 won't go 25. The difference is there. So here I'll just not show the quadratic because I expect us to know how to use the quadratic. So let's see, the first n value will be 10, or the second n value will be, let's see if I put a minus there, is going to not be equals to negative 85 over, 85 over 7. Right. So there are 10 terms that are being added in the series. So you just used quadratic formula to remember this is your A, that's your B, that's your C. All right, that was the solution for A. Let's go to B now. B is very interesting. They say determine the sixth term of the series. Okay, ladies and gentlemen, I need us to agree on one thing here. Ne? I need us to agree that S1 is basically the sum of the first term. You agree? Because S1, I'm adding one term. This is how many terms I'm adding. Adding one term is just term 1, okay? S2 is basically, is going to be, let me cancel this. Remember, S2 adding term 1 plus term 2, right? But you can see that this guy here can change to S1 because we said T1 and S1 are equal. So S2 is basically S1 plus T2. You see? Sharp. Now let's do S3. S3 is going to be equals to T1 plus T2 plus T3, which becomes, if you check here, T1 plus T2, it's S2 plus T3. Okay, perfect. I'm sure, ladies and gents, you can see that if this pattern was to proceed like this, we're going to have Sn is the same as blah, 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 blah equals to Sn minus 1 plus Tn. What I mean is if I have 3 here I'm going to have 3 minus 1, which is 2. Here I'm going to have 3. If I have 2, here I'm going to have 2. Here I'm going to have 2 minus 1, which gives me 1. Here I'm going to have 2. So this is the very most important formula you need to know. Ne? Sn equals to Sn minus 1 minus Tn. That is the very most important formula. Now we're looking for T6. They say find the sixth term of the series. So I'm going to basically say, okay, n must be 6 because I'm looking for T6. So guys, I can easily switch things around. I can say Tn equals to Sn minus 1 minus Sn. So this went there, that went there. Right, so now we can do our substitution. Tn, which is T6, equals to S5, S6 minus 1 minus S6. My S looks like a 5. So it's going to be S5 minus S6. All right. Remember, this is the Sn formula, right? So we can easily substitute now. To say, okay, this is the exactly same thing as 5 over 2, 7, 5 plus, is it plus 15? Yes, plus 15. And then we have S6 or plus 15. And then we need to minus the n is 6 now over 2, which is 7 times 6 plus 15. Let's see what does that give us. Ne? That gives us, let's see, 5/2 in bracket 7 times 5 plus 15 minus 6/2. Then we have 7 times 6 plus 15. That gives us negative 46. Okay, so the sixth term will be negative 46. All right, I can show you the other way you could have done this. Someone could have noticed that this is a sum for linear pattern, basically. How do we check if it's linear? You can find the first three terms. So let's check. We're going to find S1. So remember S1 is 1/2. And then you have 7, 1 plus 15. What does that give us? So half of 7 times 1 plus 15 is 11. Right. Now let's see S2. We're going to replace this guy with 2 and that guy with 2. Let's see what do we get. So I'm replacing that guy with 2, 7, and then I replace that guy with 2, then plus 15. And then I get 29. I get 29. And then let's check the third one. Oh, sorry. This is a mistake here. Remember, S2 is basically S1 plus T2, right? Sharp. So S2 is giving, okay, let's see. If it's 2 there, I get 29. So I get to S2 is 29. And then S1 is 11 plus T2. So it's going to be 20. T2 will be 29 minus 11, which gives you 18. So the second term is 18. Now let's do S3. Going to be 3 over 2. And then you have this. Okay, so the SN, that's it. Let's move on, ladies and gents. Okay, let's move on. So we are here now. So here they say the third term of arithmetic sequence is -7. So we know that, okay, T3, it's -7. Then the seventh term is 9. Okay. Determine the sum of the first 51 terms. So they're looking for S51 of this sequence. Okay. So this is what I'm going to do here. I'm going to firstly determine the formula of the nth term using simultaneous equations, because this is my equation 1, that's my equation 2. So I know that, okay, -7 will be equals to A plus D, n is 3 minus 1. Remember, the formula is Tn equals to A plus D n minus 1. This is the formula for arithmetic. The value is here, the position there. Let's simplify this. Is -7 equals to A plus 2D. Right? Then you can see that, okay, therefore, -7 minus 2D equals to A. Then that is your equation 1. All right. Now we're going to do the same with 9. So I know that 9 is the same as A plus D 9 minus 1, which becomes 9 equals to A plus 8D, right? Which becomes this. I can see that, okay, this A, I can replace it with that. Okay, so I'm going to say 9 equals to minus 7 minus 2D plus 8D. All right. And then I take this that side, that gives me 16. That gives me 16. Oh, ladies and gentlemen, sorry. Okay. Paraphrase, doing nonsense.